3C is all about domain and range. Domain and range could be one of those topics that's conceptually hard at first, but we just kind of got to work through the kinks a little bit, and then it's not terrible. So the first thing I want you to do, I want you to write down the domain represents all of the X values. The range represents all of the Y values. I think the picture is helpful. So if you can draw the picture, you can see how the domain goes from the left to the right side of the X-axis graph, from the bottom to the top along the Y-axis. Okay, so it's easy if you're just looking at a set of points. Let me give a couple examples, and you don't need to write it down, but it might help you visualize what's going on. Say that I just have 3 points. If we can see the actual X values, you can just list the domain using your set notation. 1, 3, 5. You can list your range as the Y values. So when they're listed, you can see the actual numbers. But consider this graph here. There's a whole bunch of values in between the beginning and the end. So then we have to use set notation. I'm not super excited about the set notation graph. I covered some of this up. And you don't need to make like the big table or anything. But think about on a number line. And these all just have to do with X. It's kind of just getting you used to the notation. If you see a solid dot, then it's either greater than or equal to 3. So you include the equal to sign. The other way you can write it is you can use a bracket saying 3 is the smallest value, and then it goes all the way up to infinity. I like this notation the best, but sometimes the interval notation is also helpful. The way you show a bracket includes the value, a parenthesis does not include the value. That's what's really important here. All right, so like in the second example, where it's just less than 2, what are all the values? Less than 2, but not including 2. Well, think about what's all the way to the left here. That's a negative infinity. So I'd start at negative infinity, because that's the furthest on the left, all the way up to the right side, which is positive 2, and it doesn't include positive 2, so I'd also use a parenthesis. So with X, it's really important that this is the furthest to the left, furthest to the right. Furthest to the left, furthest to the right. So you can only use positive infinity for the furthest to the right, because positive infinity is always on the right side. If you use negative infinity, that's always on the left side. Okay? But here's an example of where it's just specific values. So it's in between, see how X is in the middle of negative 2 and 1. It does not include open circle for negative 2, so negative 2 would get a parenthesis, and it goes up to positive 1, where it includes 1, so you use a bracket. Does not include, does include. And then the way to write this next one, see how it goes all the way to the left. So I go from negative infinity all the way up to 0, including 0, and then I'm going to union it with 4, not included, all the way up to infinity. Okay, so this is the difference between set notation and interval notation. So let's look at some of these problems on the next page. All right, so number 1 is from the opening problem. And It might be a little hard to start with number 1, but notice that it's got open circle at 0, so it does not include 0, but it goes all the way to the right to 24 hours, so it does include 24 hours on the right. So it uses all the x values in between 0 and 24. But notice there's only certain y values. So if I list the y values, and this is from, if you want to actually read the opening problem, this is at the very beginning of the chapter before lesson A. All right. So we list the y values separately because they're individual values. Because the x values are all inclusive, we just say from between 0 and 24. Okay, example number 2. You must identify domain and range so that you can tell the grader you know which one's which. Domain are the x, so it goes from the left side to the right side. So what's the furthest left of the graph? That's -1, and it includes -1, and it goes all the way to the right because there's an arrow, all the way is positive infinity. The range goes from the bottom. What's the bottom value? That's your y value, including -3, and it goes all the way to the top, all the way up to positive infinity. This takes just a little bit to mess with, so just give yourself some grace. All right. Number 3, if there's arrows, that means it goes all the way to the left and all the way to the right. So your domain is -infinity to positive infinity. Now these arrows are pointing down, so it goes all the way down to -infinity, but how far does it go up? That always measures up and down is always your y value. So it goes from the -infinity all the way up to +1, including +1. So I think it's really helpful to think of your domain. Domain is from the left to the right. The range is the bottom to the top. Once you get that firmly in your brain, it helps a lot. Number 4 kind of is a little more unique because it has asymptotes. So see how this asymptote is blocking us from where x is 2. So this one's kind of easy. We just say x cannot equal 2 because it's not on the graph. It's the only value not on the graph. So we just list it as not equal to 2. That means it can equal everything else. So another way we can write that is we say from -infinity all the way to the left, all the way up to 2, but not including 2, unioned with, starting at 2 on the right side, going all the way to infinity on the left. So that's just another way you can write it. Either one of these is acceptable. Use the one that makes the most sense to you. Then for the range, we use the y. In this case, y cannot equal +1, or interval notation, all the way from the bottom up to 1, but not including 1, unioned with 1 to infinity. Okay, so then there's a couple practice problems next. So I would turn the video off, practice writing them, and then start the video back up and check your work. The domain goes from the left to the right because there's an arrow. It goes all the way to the left and all the way up. So I'm going to go -infinity all the way to the left and trace it until I get to what x value. The furthest x value is right, and it includes, or 8, and it includes 8. The range, the bottom value is -2, and it goes all the way up to positive infinity. If you need to stop the video and change B according to what you just saw, do that. The domain, because the arrow here, this means up and to the left all the way. This is up and right all the way. So that means the domain all the way to the left, all the way to the right, negative infinity to positive infinity. The range, I can see it goes all the way up on both sides, but this is my lowest bottom point, so I have to use my -1 as my y value, all the way up to infinity. So these are how you interpret domain and range when you're looking at the graphs. The harder part is when we go to the equations. So what are the big problems in math? Okay. So the big problems in math, what are the things we can't do? The first big one, we can't divide by 0. So think about, we can't do that. We can't put 0 in the denominator. So if you recall, because we can't divide by 0, that actually corresponds to number 4. This asymptote blocks the graph because we can't put 2 into the equation. It would create a 0 in the denominator. The second big problem is we can't square root a negative. All right. So these two problems are the things that you look for. Sloppy writing there. These are the things you look for in an equation. If you see one of these two things, those are what preclude you from finding a domain. All right. So if we look at this chart here, if we start with x squared, I would include this chart under your big problems because it kind of helps a little bit. If it's a regular equation with no problems, we can just say x belongs to the real numbers. Another way you could write that, it just means you can have any value negative infinity to infinity. If you see a square root sign, you can only use positive numbers. So we say that x has to be greater than or equal to 0. So your interval would start at including 0 all the way up to infinity. If we see an x in the denominator, we just say x cannot equal any value that would create a 0 in the denominator. In this case, it's just 0. Remember, that was where we did the negative infinity up to 0, not including 0, union with not including 0. This is the alternate way to write that. And the last one is both of the big problems, x in the denominator and a square root. So that just means x has to be a positive value, not equal to 0. So we would start not including 0 up to infinity. You don't need to know both of these. You can either pick this version of how to write it or the interval notation of how to write it. Either way is okay with me. So when I look at letter 5A, I see a square root sign. So if you look back, the square root sign says this value has to be greater than or equal to 0. So that means x minus 5 has to be greater than or equal to 0. So now we just solve it for x. That means that x has to be greater than or equal to 5. I'm not going to worry about range in this case. I can show you this quick. If you think about the square root graph, this graph is just shifted to the right 5, and it's going from 0 up to infinity. We only have positive square root values, so I would just say y has to be greater than or equal to 0. Y just starts at 0 and goes up with that graph. But I don't really care about the range so much for this one. The big thing is understanding how to find the domain. With this one, I see an x in the denominator. That means that whatever is in the denominator, write the whole thing down. X minus 5 cannot equal 0. So in this case, we're just saying x cannot equal 5. And that's all we're going to do with that one. This one has both the big problems. It's in the denominator and it's under the square root. That means x minus 5 has to be greater than 0 and cannot equal 0 because it's in the denominator. So x has to be greater than 5. So I would say on these problems, just worry about the domain values and just find what x can equal or not equal. Then for the last problem, they want you to use technology. So go ahead and get your calculators out, enter f of x into your y equals, and graph it. And I'd probably just graph it on a standard negative 10 to 10. So if you want to zoom standard, if you're not in the in a good window, and if you look at the graph, this particular graph kind of goes like that. So we need to figure out what is that top point so I can figure out, because it doesn't affect my range, right? If I see negative x to the fourth, I know both these sides are going all the way down. So my domain is just negative infinity to infinity. What this point affects is the range. So we can actually use the calculator to help us find that coordinate point. So if you have this graph and you want to have the calculator figure out what that maximum point is, you're going to push second, trace, and you're going to have the calculator calculate this maximum point. You have a list of options, choose the maximum, and it's going to say the left side. And so you want to take your cursor and put the cursor to the left of the highest point and push enter. Then move your cursor to the right side, and notice the calculator says the right side or the right whatever. Hit enter again and hit enter a third time for a guess, and you should get this coordinate point of 0.794 negative 5.81. I didn't make my parentheses big enough. So when you do that, you can see the highest y value is negative 5.81. So it's going all the way down from negative infinity all the way up until I get to this point, negative 5.81 in 3 sig figs. So that's how you use technology to help you find these values. So I'm just doing a quick little sketch. I'm now going to do the exact same thing with letter B. And when I graph letter B, the first thing I want you to notice, we can see that x is in the denominator. So there's going to be an asymptote at 0. And it kind of goes like this. And it kind of goes like this, right? So notice we don't really need the technology part to find max and mins, because notice how this graph goes all the way to the left, all the way to the right, but we have to take 0 out because 0 is in the denominator. So we can just say for the domain, x cannot equal 0, but for the range, it goes all the way down and it goes all the way up. So every single y value, we can say y belongs to the reals. We can say negative infinity to infinity, however you want to say that. But you don't have to repeat it. You're just saying which y values would be on there. And right here, I can see it uses all of them. So that's all we would need.